The National Electrical Code, or NEC, mandates that wire joints must be mechanically secure, as stated in NEC Section 110.14b. Twisting wires together is a method to achieve this required mechanical security. There are several benefits to twisting wires, including improved electrical contact. When wires are twisted together, it creates multiple points of contact. This has the benefit of reducing resistance and improving the electrical conductivity of the joint. Increased holding strength is another benefit. Twisted wires are more likely to stay connected even when subjected to vibration or stress. Also, twisted wires are easier to maintain. Twisted wires are less likely to come loose over time, reducing the chances of arcing and overheating. While wire nuts can technically create a secure connection even without twisting the wires, it is generally not recommended. Twisting the wires beforehand introduces an additional safety measure and ensures the connection is as robust as it can be. Regarding speed, twisting wires together does take slightly longer than just spinning on a wire nut. However, the few extra seconds needed to twist the wires are well worth it for the added safety and reliability that it provides. While some electricians might contend that twisting wires together is not always needed, it is generally advised to do so as a standard practice. This helps to guarantee the best possible electrical connection. The advantages of twisting wires outweigh the slightly longer installation time. Therefore, it is a recommended practice for ensuring electrical safety and reliability. The goal is to reduce resistance in the circuit. Resistance in a circuit can lead to heat, and heat can lead to fire. By twisting the wires, you create more surface area for the electricity to flow, which reduces the resistance. This is especially important in high current circuits. Firstly, inspect the wires to ensure they are in good condition and free from damage. Secondly, strip the insulation from the ends of the wires, exposing enough bare wire to make a proper connection. Thirdly, hold the wires together, ensuring the bare ends are aligned. Fourthly, use pliers or your fingers to twist the wires together in a clockwise direction, creating a tight, secure connection. Fifthly, check the connection to ensure it is mechanically sound and that the wires are tightly twisted together. Sixthly, apply a wire nut to the twisted wires, screwing it on until it is snug and secure. Seventhly, give the wire nut a gentle tug to ensure it is properly attached and the wires are not loose. Eighthly, insulate the connection with electrical tape to provide additional protection and prevent accidental contact. Ninthly, carefully place the wires and connection back into the electrical box, ensuring they are not overcrowded or strained. Tenthly, secure the electrical box cover to complete the installation. Always use the correct size wire nuts for the size and number of wires being connected. Over or undersized wire nuts can lead to loose connections and potential hazards. It is also important to ensure that the wire nuts are properly tightened to provide a secure connection. Some electricians prefer to use the specialized wire nut tool to tighten the wire nuts, ensuring a consistent and secure connection. In addition to twisting the wires together, some electricians also like to solder the connection for added security and conductivity. Soldering involves melting a metal alloy onto the connection to create a permanent bond. This can further reduce resistance and improve the reliability of the connection. However, soldering requires additional skills and equipment, and it is not always necessary for every electrical connection. Wire gauge is the standard unit of measurement used to describe the diameter or thickness of a wire. The NEC specifies the appropriate wire gauge for different applications based on the amount of current the wire will be carrying. Using the wrong wire gauge can lead to overheating, voltage drop, and even fire hazards. It is important to consult the NEC or a qualified electrician to determine the correct wire gauge for a specific application. The NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It covers everything from wiring methods to overcurrent protection to grounding and bonding. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important for electricians and other electrical professionals to stay up to date with the latest version of the NEC to ensure safe and compliant electrical installations. Grounding and bonding are critical safety measures in electrical systems. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. Proper grounding and bonding can significantly reduce the risk of electrical shock and fire hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to wiring and equipment. It is important to select the correct size overcurrent protection device for a specific circuit based on the ampacity of the wires and the load being served. Arc fault circuit interrupters, or size, are a type of circuit breaker that can detect arc faults, which are a common cause of electrical fires. Size are designed to trip a circuit breaker when an arc fault is detected, preventing the fire from starting. The NEC requires a size in many locations throughout a home, including bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, or GFCIs, are another type of circuit breaker that can detect ground faults, which can cause electrical shock. GFCIs are designed to trip a circuit breaker when a ground fault is detected, preventing electrical shock. The NEC requires GFCIs in many locations where water is present, such as bathrooms, kitchens, and outdoor areas. Electrical boxes are enclosures that protect electrical connections from damage and provide a safe place to terminate wires. Electrical boxes come in various shapes and sizes to accommodate different wiring configurations. It is important to select the correct size electrical box for the number of wires and devices being installed. Wiring methods refer to the different ways that electrical wires can be installed in a building. Common wiring methods include non-metallic sheaths cable, or NM cable, also known as Romex, metallic conduit, and cable tray. The NEC specifies the allowable wiring methods for different applications based on factors such as the environment, the voltage, and the type of building. The electrical permits are required for most electrical work to ensure that the work is performed safely and in compliance with the NEC. Electrical permits are typically obtained from the local building department. A qualified electrical inspector will inspect the work to ensure that it meets the requirements of the NEC. Hiring a qualified electrician is essential for ensuring safe and compliant electrical installations. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and effectively. They are also familiar with the NEC and local electrical codes. When hiring an electrician, it is important to check their credentials and ensure they are licensed and insured. Regular electrical maintenance is important for preventing electrical problems and ensuring the safety of your electrical system. Electrical maintenance includes inspecting wiring, tightening connections, testing overcurrent protection devices, and replacing worn or damaged components. It is recommended to have your electrical system inspected by a qualified electrician at least once every 3 years. Troubleshooting electrical problems can be challenging, but there are some basic steps that can be taken to identify and resolve common issues. These steps include checking circuit breakers, testing outlets, and inspecting wiring for damage. If you are not comfortable troubleshooting electrical problems yourself, it is best to call a qualified electrician. Electrical safety is paramount when working with electricity. Always turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses. Never work on electrical circuits while standing in water or on a wet surface. If you are unsure about any aspect of electrical work, consult a qualified electrician. When working with electrical circuits, it is important to understand the concepts of voltage, current, and resistance. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical charge. These three quantities are related by Ohm's law, which states that voltage equals current times resistance. Understanding Ohm's law is essential for troubleshooting electrical problems and designing electrical circuits. Electrical circuits can be either series circuits or parallel circuits. In a series circuit, the components are connected in a single path, so the current is the same through all components. In a parallel circuit, the components are connected in multiple paths, so the voltage is the same across all components. Understanding the difference between series and parallel circuits is essential for designing and troubleshooting electrical circuits. Electrical drawings, also known as blueprints or schematics, are used to represent electrical systems and circuits. Electrical drawings typically include symbols for various electrical components such as wires, switches, outlets, and lights. Understanding electrical drawings is essential for electricians and other electrical professionals.